Hello, good day viewers. In this tutorial, we are going to find a solution to this system of logarithmic and exponential equations. We are given that y equal to 1 plus log of x with the base of 4. And the second equation, x raised to the power of y is equal to 4 to the power of 6. And we want to find the real values of x and y that can satisfy both equations. All right, let's get started with the solution. Let me call this equation number 1, and this should be equation number 2. From equation number 1, which is a logarithmic equation, remember that log of any number having the same base as that number will always be equal to 1. For example, if we have log a base a, this is always equal to 1. If that is the case, we can express 1 as log of 4 with the base of 4, right? Therefore, from that equation, we have y equal to log of 4 with the base of 4 plus log of x with the base of 4. This is always true. I remember this law that says if you have log of a with the base of b plus another log of, say, c with the base of b, provided that they have common bases and the operation between them is plus, you can always write this as log of a multiplied by c with the base of b. So we can apply the same thing here. Therefore, this will be y equal to log of 4x with the base of 4. So y equal to log of 4x if you multiply 4 by x with the base of 4. Now we are going to apply definition of logarithm here. Remember that if you take the base and raise it to the power of y, it will give us 4x from definition. Therefore, 4 raised to the power of y will be equal to 4x. I want us to make x the subject here by dividing both sides by the coefficient of x. Therefore, x will be equal to 4 raised to the power of y divided by 4. And you can apply one of the laws of indices here. X is equal to 4 raised to the power of y minus 1, because naturally 4 at the denominator has a power of 1. So this is the value of x. Now let us take the second equation. The second equation is x to the power of y equal to 4 to the power of 6. But we have already seen that x is equal to 4 to the power of y minus 1. So we can substitute it back here. So instead of x to the power of y, we have 4 raised to the power of y minus 1, also raised to the power of y, right? And this is equal to 4 raised to the power of 6. From the left hand side, from one of the laws of indices, these powers can multiply. So we have 4 raised to the power of y times y is y squared, and y times negative 1 is negative y, and this is equal to 4 to the power of 6. Since the bases are the same, it implies that even the exponents are also the same. So we are going to say that y squared minus y is definitely equal to 6. And this is a quadratic equation. Let us solve for the value of y. If you bring everything to left hand side, you have y squared minus y, then minus 6. This is equal to 0. You can solve this by factorization. Think of two numbers that you can multiply together to get negative 6. And when added up together, you get the coefficient of y, which is negative 1. The numbers are negative 3 and positive 2. So we have our two factors, y minus 3 multiplied by y plus 2. And the whole of this equal to 0. Now we are going to set each factor to be equal to 0, which implies that y could either be equal to positive 3 or negative 2. So these are the values of y in these equations. But remember that x is equal to 4 to the power of y minus 1, right? But x is equal to 4 raised to the power of y minus 1. So when y is 3, we have that x is equal to 4 raised to the power of 3 minus 1, which is equal to 4 raised to the power of 2. Therefore, x is equal to 4 to the power of 2, which is 16. So this is one of the values of x, which implies that when x is equal to 16, y is equal to, what is the value of y there? 3. Then you take the second value of y, which is negative 2. Remember, the equation is still x equal to 4 raised to the power of y minus 1. X equal to 4 raised to the power of y, which is negative 2, then minus 1. And this is equal to 4 raised to the power of negative 3. And 4 raised to the power of negative 3 is the same thing as 1 divided by 4 raised to the power of 3. So x is equal to 1 divided by 4 raised to the power of 3. And 4 raised to the power of 3 is 64. Therefore, x is equal to 1 divided by 64. And here is another value of x. So when x is equal to 1 divided by 64, the value of y there will be negative 2. So these are the two values of x and y. We have these two. We can even bring them together, 16 and 3. We have 16 and 3, or 1 over 64 and negative 2. So these are the values of x and y in these equations. So let me give you this little task. Try to check whether these two solutions can satisfy our original problems, which are these two equations. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.